Till now we have seen Murray machines. Now let us see a Mealy machine. Now the question is, construct a Mealy machine. Mealy machine is nothing but for every state, for every input there will be an output. It is not just output is not just associated with the state. For every state, for every input there will be an output. So the question is, construct a Mealy machine that accepts all binary strings, which means sigma input equal to 0, 1, and now we should produce 2's complement of the binary number. So therefore output is also a binary number which should be 2's complement of the input. If I say input is some number, output has to be 2's complement of that. Assume that the string is read from LSB to MSB and n carry is discarded. Okay, so before actually doing this problem, let us try to do some simple problem where I'll take a binary number as input and I'll produce 1's complement as output. 1's complement as output. So that will be simple. What is 1's complement? Let us say if I have 0, 1, 1. What is 1's complement? 0, 1, 0, 0. Wherever you see 0, wherever you see 1, convert it to 0. Wherever you see 0, you convert it to 1. So that must be very simple. I'll be in initial state. If I see a 0, I am going to convert it as 1. If I see a 1, I am going to convert it as 0, and just one state is required, nothing else. So if you have to trace out and see how this one is working, I am talking about 1's complement, not 2's complement. I didn't reach this problem yet. Okay, so if the input is 0, let us say 1, 0, 1, 1, then I am going to start in Q0. On 1 I will be in Q0. Q0 on 1 is going to print 0, and again on 0 I will be in Q0 only. Q0 on 0 is going to print 1. Again on seeing 1 I will be in Q0 itself. Q0 on 1 is going to produce 0. Again on 1 I am going to in Q0 only, and Q0 on 1 is going to produce 0. So that is how we got 1's complement, right? So 1's complement is easy, simple. So whenever you see a 0 you are going to print 1, and whenever you see a 1 you are going to print 0. But 2's complement is not that easy, and moreover 2's complement has to be, let us talk about 2's complement first. Let us say I have a number 1 0 0 1 1 0 0. Okay, I want to find out the 2's complement. How to find the 2's complement of this? First you find 1's complement, which is 0 0 1 1, and then you add a 1. Then what do I get? 0 1 0 0. This is the 2's complement. So let's take one more example. 1 1 1 0 1 1 0 0. So I want to convert this to a 2's complement. First convert it to 1's complement. 1's complement is going to be 0 0 0 1 0 0 1 1. And now in order to convert it to 2's complement, add a 1. So what do I get? 0 0 0 1 0 1 0 0. Simply adding 1, right? 1 plus 1 is 0, and again you get a carry here. 1 plus 1 is 0, so again you will get this one and carry here. So that is how you got. Now you just check these two numbers. This is the original binary number and this is the 2's complement of it. If you look at this, if I am reading from LSB to MSB, if I have zeros in the beginning or zeros from the LSB side, LSB is this least significant bit and most significant bit. If I am reading from LSB to MSB, whenever I have zeros, I am leaving them as zeros, and whenever I see first one, I am leaving it as 1, and whatever is there after that first one, it is going to be complemented. Check this. All the zeros are left as zeros, and whenever I see first one, that is left as 1, and after that whatever I see, I am complementing this. You will understand better in this example. See, whatever are zeros, that will be left as zeros. Initial two zeros are left as zeros, and then once I see first one, that will be left as 1 itself, and after that whatever number is there, that will be once complemented, and after that whatever number is there, that will be once complemented, which means 0 1 1 1 1. You can take one more example. Let us say 1 1 1 0 0. What is the ones complement of it? 0 0 0 1 1. What is the 2's complement of it? Add a 1 to it, then it is going to be 1 0 1 0 1 0 0. Whatever is the least significant zeros, you are going to write it as it is, and the first one you are going to write it as it is, and after that whatever is remaining we are going to take 1's complement of that. So by this you should understand one logic. If I am going to start from LSB, whatever are zeros there, I am going to leave them as zeros, and after seeing the first one from the LSB, I will leave it as 1, and after that whatever I see I am going to apply 1's complement. Again see this, whatever are zeros I am going to leave it as zeros, and whenever I see the first one, that first one will be left as it is, and whatever is the remaining string, that will be like this. What if there are no zeros at all? Then it is going to start with 1 itself, right? What if there are no zeros at all? Let us say, you can even talk about this example, 1 0 1 1, there are no zeros at all. Let's see how it works. So it is going to be 0 1 0 0 is the 1's complement, and 2's complement is 1 0 1 0. So what happened? Whenever I see the first one, that first one is going to remain as it is, and after that everything is going to be complemented, right? So we don't care what happens after the first one. So if there are zeros, they will be left as it is, and the first one will be left as it is, and whatever is remaining on the left of it, that will be 1's complemented. Okay, so now let's construct the Mealy machine for this. The Mealy machine will actually look like this. I'm assuming that I'm reading from LSB. So initially I'll be in state Q0. In this state I'll be seeing zeros, and I'll be leaving them as zeros. Whenever I see a 1, I'll remember that I have seen a 1, and I'll print 1, and I'll go to next state, and this state will actually complement everything, which means if I get a 0, 0 is printed, 1 is printed, and if I get a 1, 0 is printed, right? So if I have to explain this, I'll take an example. Let us say the example is 1 0 1 1, or maybe I'll take another example, 1 1 0 0. What is 1's complement of it? 1's complement is 0 0 1 1, and what is 2's complement of it? 2's complement is 1 0 1 0 0, right? So I'll take this number 1100 and I'll give to this automata Mealy machine, and I'll get this output. See this, 1100, Q0 on 1 is going to Q1, and now Q0 on 1 is going to Q1 and is going to produce 1, right? And we are supposed to read from the ending, right? We are supposed to read from the LSB, which means I should write it as 0011. Okay, now Q0 on 0 is going to produce 0 itself and stay in Q0 only. Again Q0 on 0 is going to stay in Q0 itself and going to output 0 only, and Q0 on 1 is going to produce 1 and is going to go to state Q1, and Q1 on 1 is going to Q1 itself and is going to produce 0. So what is the answer? You have to count it in the reverse order, which means the 2's complement is 0010. Got it? So this is how it is built.